All right, everybody, let's get started on lesson 4, ratio tables. The learning objective for this lesson is I can use a ratio table to find equivalent ratios. So we're not necessarily simplifying here. We might be dividing, we might be doing some multiples, basically we're going to work with a table to find ratios that are equivalent. Another word for equivalent is that they are like equal to each other. We need to look at this really quick just because we're going to use it on the next page. A punch recipe uses 1 container of soda and 3 containers of juice to make 1 batch. So for 1 batch of punch, it needs to have 1 container of soda, 3 containers of juice. So right here, if you were making 2 batches of punch, then you would need 2 sodas, and double of that, you would need 6 things of juice. So then if you had 3 batches, you would need to triple it. So now you're going to need to use 3. So for a single you needed 1, for a triple you need a 3. For a single you needed a 3, now to triple it you need a 9. All right, so what we're going to do is we're going to look on the next page. Oh, by the way, that was page 39. On the next page, page 40, they made this into a table. So the soda per juice. For 1 batch, you needed 3 juices. For 2 batches, you needed 1 soda and 3 juice. For a double batch, 2 soda, 6 juice. For a triple batch, 3 sodas and 9 juice. So let's talk about a ratio table and equivalent ratios. The quantities in the opening activity can be organized into a table. That's this down below. This is called a ratio table because the columns are filled with pairs of numbers that have the same ratio. So this is a ratio, this is a ratio, and this is a ratio. 1 soda for 3 juice, 2 sodas, 6 juice, 3 sodas, 9 juice. These ratios can be written as fractions. 1 over 3, 2 over 6, 3 over 9. They're all equivalent because they can all simplify down to 1/3. So 3/9. When you divide the numerator and denominator by 3, you get 1/3. 2/6. When you divide the numerator and denominator by 2, you get 1/3. So they're all equivalent. Equivalent ratios express the same relationship between quantities. They're all equivalent to each other. It's the same type of a ratio. It's just with this example, how many batches. So this is a single batch, a double batch, a triple batch. But it's still the same ratio when you simplify it down. So we're going to use tables a lot in this lesson. And most of the time we're just going to fill in the blank spots of a table. So let's look at example 1. To make yellow icing, you mix 6 drops of yellow food coloring, 6 drops of food coloring with 1 cup of icing. So how much yellow food coloring should you mix with 5 cups of icing to get the same shade? So if 1 cup you use 6 drops, for 5 cups, how many drops of the yellow do you need? Well, when you set it up like a ratio table, it looks pretty easy. 1 times 5 is 5. So if you multiply the denominator by 5, you have to multiply the numerator by 5. 6 times 5 is 30. So you would need 30 drops of yellow food coloring if you have 5 cups of icing. All right, let's do an example of this. Let's go down to the bottom, and we're going to do example A right here. A patient receives 1 liter of IV fluids every 8 hours. So 1 liter in 8 hours. At that rate, how many hours will it take to receive 4 liters of IV fluids? So if you multiply the numerator, 1 times 4 would equal 4. Then you need to do the same here. Multiply by 4 in the denominator. 8 times 4 is 32. So your answer is going to be, it would take 32 hours. So over here, 32 hours. All right, so that goes with example 1. Let's take a look at example 2. This is going to be a little bit different because there's more than one step. It says, In a recent year, Joey Chestnut won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes. He ate 66 in 12 minutes. If he ate at a constant rate, determine about how many hot dogs he ate every 2 minutes. Now, let's see what it says. It says, divide each quantity by one or more common factors until you reach a quantity of 2 minutes. So Chestnut ate about 11 hot dogs every 2 minutes. Let's see what they did. First, they divided 12 by 2 to get 6, 66 by 2 to get 33. Then they divided 33 by 3, that gave you 11. 6 by 3 is 2. Now the reason why they divided by 3 here was because we're trying to get to a 2 in the denominator. So my question is, how could you make this faster? Look it, you could have done it in one step. You could have done 12 divided by 6, that equals 2. 66 divided by 6, sorry, we have to divide by the same thing, 6 and 6 equals 11. So honestly, this could have been done in less steps. Let's take a look down at the bottom. All right, at the bottom of page 40, to make cranberry jam, you need 12 cups of sugar for every 16 cups of cranberries. Find the amount of sugar needed for 4 cups of cranberries. Now, I'm just going to be straight up honest with you. You could do 16 divided by something equals 4, because we all know 16 divided by 4 is 4. So you can divide 12 by 4 too. 12 divided by 4 is going to give you 3. You don't really have to do an in-between step on this one. Now, sometimes you might need to do an in-between step to get an easy number. Like, for example, between 16 and 4, you could use 8. So that's going to be another multiple between these numbers. So if you needed to, you could do 16 divided by 2 is 8. 12 divided by 2 is 6. And then the next step, you could divide them both by 2 again. Divide by 2, it gets 4. 6 divided by 2, it gets 3. But honestly, if you can just take one step, why not do it? So the answer here is you need 3 cups of sugar for 4 cups of cranberries. So the answer for how much sugar? 3 cups. All right, now we're going to talk about scaling. And in scaling, you do use more than one step. So you do have to do this middle part for scaling. So let's read what scaling is. Multiplying or dividing 2 related quantities by the same number is called scaling. Sometimes you may need to scale back and then scale forward. This is the part we need to circle. So right here is the key. Because what you're going to see in the example is you have to scale back and divide. Then scale forward, you can multiply. So I'll show you how that works. Look at example 3. Cans of corn are on sale at $10 at 10 cans for $4. Find the cost of 15. So 10 cans for $4. We want to get to 15 here. And we can't just easily 10 times something or 10 divided by something doesn't get you 15. So we have to do something in the middle before we can get 15. So look, this table is down here with the answers in it. There's no whole number by which you can multiply 10 to get 15, so scale back to 5. If you scale back, if you divide by 2 and get to 5, you divide 4 by 2 and get to 2, then you can multiply 5 by 3 to get 15, so multiply 2 by 3 to get 6. 6 is going to be your answer. 15 cans of corn is going to cost you $6. So we had to scale back to get a number that would easily be able to scale forward and multiply to get that number. Okay, let's take a look at example 4. So going from 3 to 4. All right, example 4 on page 41. Joe mows lawns during his summer vacation to earn money. He took 14 hours last week to mow 8 lawns. At this rate, how many lawns could he mow in 49 hours? So we have 14 hours, and we want to see how many he can mow in 49. Well, here's the problem. Is there a whole number which you can multiply 14 times something gets 49? No. That's our problem. So we need to scale back. Now, if you think about this, 49, 7 times 7 is 49. So if we could scale 14 to 7, if we could scale back to 7, then we could scale forward to the 49. So here's the work. 14 divided by 2 would get you 7. So 8 divided by 2, you have to do the same to the numerator and denominator, would be 4. 7 times 7 is 49. 4 times 7 is 28. So Joe can mow 28 lawns in 49 hours. All right, now I believe if we go to the bottom, example C, that is going to help us scale back and scale forward. So let's go down to this one right here. A child's height measures 105 centimeters. Estimate her height in inches. So we have 25 and 10. We're trying to get to 105. Here's how you could make it a little bit easier. If we scale back, what if we scaled back and got 5 right here? If we got 5, we could multiply up to 105 because 25 doesn't. If you do 25 times 4, that's 100. You can't do another one. So what if we brought it down to 5? 25 divided by 5 is 5. So watch. 25 divided by 5 is 5. Now, if we divide the numerator by 5, we have to divide the denominator. So 10 divided by 5 is 2. Now, the thing is here, you have to see 5 times what gives you 105. You could use a calculator. You could think about it. Like 25 times 5 would be 125. What's 24 times 5? In the end, whether you use a calculator or you multiple up with your fingers or whatever you want to do, the answer is going to be 5 times 24 gives you 105. So then you have to do 2 times 24 to get your answer here. So when you double 24, it's going to give you 48. So your answer, her height in inches, when she measures 105 centimeters, would be 48 inches. So 48 inches is the answer. All right. Now, the next step is going to be page 42. On page 42, I'm just going to walk you through this example. It's just another way to look at the scaling back and scaling forward situation. On her vacation, Leah exchanged $50 American and received $60 Canadian. Use a ratio table to find out how many Canadian dollars she would receive for 20 American. So if you set up this table, we're trying to get from 50 to 20. Now there's no easy way to do that. You can't just say, oh, 50 divided by this gets you 20. So you have to do it in steps. So if you scale all the way back down to 5, 5 can scale up to 20. 50 divided by 10 is 5, so you have to do that to the top. 60 divided by 10 is 6. 5 times 4 is 20. 6 times 4 is 24. You have to make sure that whatever you do to the top, you do to the bottom. Okay, so now here's our answer. She gets $24 in Canadian for every $20 in American. All right, your job is to practice this. And in class, we're first going to practice this on page 42. And here are the ones that I want you to do. On page 42, I want you to do number 1, 2, and 3. And that's it. 1, 2, and 3. So I'm going to go to number 1 first. I want you to pause this video and do number 1 and then play it and see if you got it right. All right, go ahead, pause it. Do number 1. Okay, let's see if you got it right. So Santiago receives an allowance of $7 every week. How much total does he receive after 4 weeks? So check this out. If he has $7 in 1 week, how do you get to the 4? You multiply by 4. 7 times 4 is going to give you your answer of 28. So he gets $28 in 4 weeks. All right, do number 2. Pause it and do number 2 and then play it and check it. Number 2, Tanya runs 8 kilometers in 60 minutes. At this rate, how long would it take her to run 2 kilometers? So we know the kilometers are 8 and 2. She can do 8 in 60 minutes. So how many can she do in, how many minutes does it take her to do 2? Well, look, you could do a 1 step here because 8 divided by 4 is 2. Now, what about 60 divided by 4? Sorry, that is messed up right there. 60 divided by 4. Well, think, 30 divided by 2 is 15. 60 divided by 4, double both of those, it's going to be 15. 2 15s would give you 30, 2 more would give you 60. So your answer here is going to be 15 minutes. It would only take 15 minutes to run 2 kilometers. All right, let's do number 3. Lamika buys 12 packs of juice boxes that are on sale and pays a total of $48. Use a ratio table to determine how much Lamika will pay to buy 8 more packs of juice boxes at the same store. Okay, so the number of juice boxes, she wants to buy 12 packs. They're on sale for $48. And it wants us to know how much would it pay to buy 8 more packs of juice boxes at the same store. So, oops. Sorry, I dropped my sheet. So, let's do 8. All right. Can't get from 12 to 8. So we're going to have to scale back and then scale up. So, what could we scale down to? Well, let's see. Maybe we could scale down to 4. If we scaled down to 4, oh, hold on, we might have trouble down here. That would do good with the number 12. What if we scaled all the way down to 1? 12 divided by 12 is 1. 48 divided by 12. See what I mean? How that's a good number for 48? 48 divided by 12 is 4. So now we have to scale up. 1 times 8 is 8. 4 times 8 is 32. There's our answer. So it would be $32. One was a little bit trickier. All right, now here is your homework. This is what you want to be able to practice on your own. The only ones I want you to do are, let's circle them. Number 1, number 2. Notice, go back to example 1 if you need help on that. Example 3 and 4 if you need help on that. And then 5A. So 5A only. All right? Cool. It's going to be a more complex table. This one's a little bit tougher than those two. All right, there's your homework.